All right, let's look a little bit at this unit of length. We use a meter, which is abbreviated with a little m to designate a meter. Let's say I want to measure, and this right here, that's the size of a meter, 1 meter. And let's say I want to measure, the width of one of my hairs. This isn't going to work very well, is it? Not at all. We're going to need a unit of measure that's a lot tinier than this to talk about what's the width of my hair. And so, what we do in the system of units that you're used to thinking about, which is, miles and yards and feet and inches, what we often do is we make new units of measure that are tinier. And I don't really know in the English system what they use that's tinier than an inch, but I just happen to know what they use in the metric system. There's a system that's used in the metric system, which is what we're using in science class, to measure distances that are really tiny, like the width across the human hair, or say a really large distance like the distance from here to the moon. And what's nice about the system that we're going to be using in class is it's all based on powers of 10, and it's consistent through any type of unit you want to use. And what we do is we use prefixes. So we use various prefixes either to scale this up, make it much bigger, or to shrink it down and make it tinier, say to measure the distance across the width of my hair. So for example, you're probably familiar with the unit, the centimeter. And if you're familiar with that, that's tinier than a meter. I mean, it's like, 1/100th of the distance across here. So it's like the thickness of my pinky, pretty much. That's about a centimeter, right about there. About a centimeter in width. And I want you to notice what's done here when we've taken this meter and we've shrunken the unit to make it something that's more reasonable for us to talk about. All we did is we just put a prefix in front of our unit. And this is what's done. You can have a centisecond. You can have a centigram. You can have a centikelvin. We were just talking about temperature. So you can use this prefix in front of anything. Hey, you can have a $1. That would be a cent. There's a clue there. A $1. That's just a cent. So a centi, that probably means 1/100th. A cent's 100th of a dollar, right? A cent is. And that's what we mean when we use this prefix. We mean take whatever the basic unit is and divide it into 100 parts, and then you've got your new unit. And that's all these prefixes do. All these prefixes do is they say take your basic unit and make it smaller by some factor of 10. Cent says make it smaller by a factor of 100. Or we can make it bigger. And we do all of that by using these metric prefixes, which I'm going to write down all the metric prefixes that you should be aware of, and you can see that in slide 3 in your PowerPoint. So let me get these written down here. So these are all prefixes that we use to take this meter and blow it up. So a decameter, we're actually taking the meter and we're making it 10 times as big. Deca, decade. A decade is 10 years. A decameter is 10 of these. Each time we go up, we're going up by a factor of 10 through these 3. So a decameter is multiplied by 10. A hectometer is multiplied by 100. A kilometer, a kilo, that's multiplied by 1,000. And then these skips all get multiplied by 1,000 again. So a megameter, that's actually multiplied by 1,000,000. A gigameter, that's multiplied by 1,000,000,000. Billion with a B. And a terameter, that would be multiplied by a trillion. That's a lot. And this is a little shorter than a mile. I think that's about the distance around the Earth. This might be the distance to the moon. I mean, you know, the scale goes up crazy, crazy large, pretty quickly. So these are representations of how we can use metric prefixes to make things larger. And say, let's say I wanted to tell somebody that I was dealing with a Deca Meter, what I would write here is this, DK with a little m. That means Deca Meter. This would mean, what does that mean? What did I just write there? And what does that mean? What am I measuring? What am I trying to tell people that I'm measuring here by writing this? This part, the last letter, always tells you what it is that you're measuring. This tells me I'm measuring a meter. This tells me I'm measuring a second. This tells me 10 seconds. That's how long the time is. And so if I would write that, that would mean 10 seconds. Or 1 decasecond. It's the same thing. So you start paying attention to that. We'll be doing quite a bit of this, but these symbols that you see after the numbers, they have meaning. There's always going to be a prefix, and then the part at the end that's going to represent the measure that you're making. I could do this as well. 1 deca Kelvin. That's 10 kelvins. That would be the temperature at 10 Kelvin, which is pretty cold, but nevertheless, that'd be the measure. Okay, now let's go to the tiny metric prefixes. Decimeter. Sorry, I always do that. A little d, that means deci, or divide by 10. A little c means centi, or divide by 100. A little m means milli, or divide by 1,000. And now we're going to skip 1,000 each time here. There's a micro. This is a Greek symbol mu. It looks like a U with a tail on the front. It's a Greek letter M, and this means divide by 1,000,000. And this is actually, if we're talking about length, this would be the appropriate unit to use to talk about the width across the human hair. The width across the human hair is roughly 30 or so micrometers. After micro, we have nano. That's divided by 1 billion. And then we go pico, million, billion, trillion, yep. It's pico. That's divided by 1 trillion. Let's see, and then we have femto and atto. Woo, that's tiny. So this is divided by 10 to the power of 15, so you divide by 10 15 times, and here you divide by 10 18 times to get to this unit here. And in our class, these really tiny prefixes are going to be important because in chemistry, you talk about things that are really tiny. And when you start talking about things that are really tiny, you have to start really scaling things down in order to be able to talk about them in numbers that sort of make sense. So these are all of our metric prefixes that you are going to be responsible to know. And you're also going to be responsible to know how to convert from one type of metric measurement, say 1 megameter, into, well, how many meters is that? Or 12.7 micrometers, how many millimeters is that? Being fluent in knowing how to convert from one metric prefix unit into another is going to be extremely important throughout this entire course. So we're going to start talking about that right now, how to do these conversions from a metric measurement in one type of unit with a metric prefix into another metric unit with another prefix. I'm going to draw a chart across the top of the board that I use to help me when I'm doing metric conversions. So the chart looks like this. I'm going to write a capital T for tera, and it's important you include the dashes. So I'm going to put 2 dashes, and then I'm going to put a capital G for giga, and then 2 dashes, and then a capital M for mega, and then 2 dashes, and then a little k, and then a DK, nope, an H, and then a DK, and then I'm going to just write my base unit here. What in the world do you mean by that? Well, this means, you know, you're talking about seconds. Am I talking about grams? Am I talking about meter? Am I talking about Kelvin? So my base units all belong here because I can use this chart for all of these things and more. And then we have a little d for deci, a little c for centi, a little m for milli, and then I'm going to draw 2 dashes and a micro, 2 dashes and a nano, 2 dashes and a pico. I could keep going. I'm not going to. I'd write 2 dashes and a femto and 2 dashes and an atto. But we won't worry about going down that far. But you should, you should know how to go down that far because we need to know about all these metric prefixes and converting one to another. And this is it. This is all you need to know to know how to convert one metric unit into another. So let's try this. Let's say, okay, Dr. K told me that the distance across a human hair was 30 micrometers. What's that in millimeters? What's that in picometers? What's in any of the units that we have up here on the chart? Well, it's pretty simple to do this. This is what's really nice about the metric system. Anytime I want to move from one spot on the chart to another, all I got to do is I'm going to count the number of spaces I move and in what direction I move. So let's say I want to know how many millimeters 30 micrometers is. So if I want to do that, what I'm going to do is I'm going to move. I got to count the spaces. So I'm starting here, and notice I'm going to move 1, 2, 3 spaces in this direction. So what do you think I do with the decimal on the number? I also move it 3 spaces in this direction. Well, wait, you say, where's the decimal on the number 30? Where's the decimal on the number 30? Is that 30? Is that 30? Sure it is. So anytime you see a number where there's no decimal written, it's understood that the decimal's at the end of the number. A lot of times you'll see a number written with a decimal, sometimes you won't. If there's not a decimal on the number, you just stick it on the end. So here I've got my number written, 30, and I want to move it to the milli spot. So I moved, once again, you don't count where you start. You start somewhere, and then notice I'm going to move 1, 2, 3 spaces. I don't count 1, 2, 3, 4. That's a mistake I see students make a lot. So I'm starting at micro, and I'm moving 1, 2, 3 spaces in this direction. So I move my decimal 1, 2, 3 spaces in this direction. Well, I ran out of numbers. What do you think I stick in that empty spot there? Probably a 0. Yeah, it makes sense. Sure. You stick zeros in the empty spaces when you start moving the decimal and you run out of numbers. So there we have it. I know it. I know that 0.03 millimeters is going to be the same thing as 30 micrometers. That's the basic idea of using this chart. And if you understood what I just did, you can do it for anything now. You can do it for all sorts of conversions. And we'll do a few of them, but just know that this is the basic idea. That's it. Pretty simple. A couple things I want you to keep track of here. When I see a unit, let me write this just a little bit bigger. When I see something like 0.03, little m, I want you to think about what these letters mean. Very important to do so. Let me show you why. Let me show you why. You might see this. You might see this. You might see this. you might see this. Now these are all different measures that I've written down. They're all different things. But you should know what they mean. All of these letters are conveying information to you that you need to pay attention to. In this case, remember, actually in all cases, we're going to try to remember that the last part of the letters that you see after a number, that refers to the unit that you're dealing with. I'm dealing with a meter here. This tells me how I've modified the meter. This tells me a millimeter. And this gets confusing, right? That's an M and that's an M. This M means something different than this M. This M means milli. This M means meter. This M, there's just an M there. If I just see one letter after the measurement, after the number, then there's no prefix associated with it. That means I'm here. If I'm right? If I was gonna place this somewhere on the chart, I'd put it right here. If I was going to place this on the chart, I'd start here at the milli. If I was going to put this on the chart, well, I'm dealing with a meter, but that's a micro unit. I'd start right here. Where would I put this on the chart? I'm dealing with a meter. This is mega, so I'm going to start here. And I'm pointing this out because I sometimes see students make the mistake that they'll see, oh, there's an M, that's a meter. And then they start here, and then they mess up. All right, let's do a few more conversions, a couple more. I'm actually going to look at, I'm on slide 4 on the PowerPoint. There's a few problems to work through there. Let's try a couple of them. I'm going to skip the first one. Let's do this one. 0.017, and then I see a micrometer, and I want to know how many nanometers that is. Could you do that problem? Why don't you try it? So if I'm going to do this problem, let me make these clear here. I'm going to take the measurement that I have, 0.017. I'm dealing with a meter, so we know it's a length measurement. But I'm going to stick that in the micro portion of the chart. So I'm going to stick that right here. And I see that I want to move to the nano position, because I want to know how many nanometers there are. Well, let's see. If I'm at micro and I want to move to nano, I'm not moving this way. I'm moving this way. I see I got to move 1, 2, 3 spaces in this direction. So I move that one's easy. I move this decimal 1, 2, 3 spaces in this direction. So let's see. 1, 2, 3. It's 17. So there are 17 nanometers in 0.017 micrometers. These are identical measurements, and they're written in slightly different ways. Now, which way is more appropriate to write it in? You really can do it either way you want, but generally speaking, what we try to do is we try to write our numbers somewhere as a number between 1 and 100. So because 17 is between 1 and 100, I'd appreciate the number being written like this rather than this, because we can kind of think about numbers between 1 and 100 kind of easily. And so generally speaking, when we choose a unit or a prefix for our measurement, we try to choose one so that the number that we end up writing is somewhere between 1 and 100. That's what you're doing there. Let's try another one here. Let's look at this problem here. 0.017 kilograms. How many milligrams is that? So if I was trying this conversion, I'd first recognize I'm dealing with grams. The prefix conversion that I'm looking at, I'm converting a kilo to a milli. That's not a meter gram, that's a milligram. This M here means milli. The unit we're dealing with is grams. So my base unit in this problem is grams. I've got 0.017 kilograms, so I'm going to stick that right here. 0.017 in the kilo space. And I see I'm moving all the way down here to the milli space. Well, how many spaces do I got to move and in what direction? Let's see. I'm going to move this way, and I'm going to move 1, 2, 3. This does count as a space. 4, 5, 6 spaces in this direction. So I'll do that with my number. 0.017. I'm going to move it 6 spaces. 1, 2, 3. Got to move 3 more spots. 4, 5, 6. There's my decimal. Empty spaces go 0. So it looks like 17,000 milligrams is the same thing as a kilogram. And now I think it's time that you can sort of see that I'll just do this for a whole bunch of different things on the chart, right? Hectogram. I would take this and move it 1 spot. So that's going to be 0.17 hectograms. That's going to be the same thing as 0.017 kilograms. If I move 1 more space over, 1.7 decagrams, that's going to be the same thing as 0.17 hectograms. That's the same thing as 0.017 kilograms. Moving 1 more space over, 17 grams, right? 17, just move it 1 spot. 17 grams, that's the same thing as 1.7 decagrams, 0.17 hectograms, 0.017 kilograms. You get the point. If I move 1 more spot over, 170 decigrams or 1,700 centigrams. All of these are the same measure. They're identical measures. Just written, I better put a kilogram here, just written in slightly different ways. So you can see, as you move through the chart, you just move the decimal 1 space. You should try the problems on slide 4 of the PowerPoint, doing the metric conversions. There's some extra ones for you there, and we'll try some in class as well.